Hi, and welcome to Meetings in Math. You are here for section 7.3, the Pythagorean Theorem. Our essential question is, how are the lengths of the sides and the hypotenuse of a right triangle related? Today you'll need your Jaguar dots on section 7.3, a pen or a pencil. A highlighter might be useful. Leave your calculators behind, but you might want to bring with you a multiplication table. Your bright ideas, your self-confidence, and always bring your problem-solving skills. Let's begin by labeling the parts of a right triangle. Let's begin by looking at the right angle on a right triangle. The right angle of the right triangle is going to lead us directly to the hypotenuse, which is the side opposite of the right triangle. And the hypotenuse we are going to label as C. And again, remember, it's always opposite of the right angle. So start with your right triangle. Go across and label that your hypotenuse, and we're going to label it with the variable of C. And then the other two sides are called legs, and you can label those A and B. It doesn't matter which one's A and which one's B, it's interchangeable, but they are both called the legs. Now that we have our triangle labeled, we're going to talk about the Pythagorean Theorem, which many of you are probably familiar with and have heard about it, but we're going to go ahead and formalize it. The Pythagorean theorem says that the sum of the two legs squared is equal to the hypotenuse squared. Now that's a mouthful, and that's why we give them variables. And so what we say in variables is that a squared plus b squared, that's the sum of the two legs, is equal to c squared. It's a whole lot easier to say, but we need to understand that it's the two legs, we're going to square those, and then add them together, is equal to the hypotenuse being squared. All right, so example 1, we're going to find the value of C. Let's begin by counting the squares on each of the legs and compare those to the squares on the hypotenuse. So if I look at the very first one, it's a 3 by 3 because this is 3 long and I actually squared it. So how many green squares do I have? I have 9 green squares. And let's look at the other side. It's a 4 by 4 orange. So how many orange squares do I have if it's a 4 by 4? Well, 4 by 4 is 16, or I can actually count them and I have 16. So now let's go look at the other one. I can count them individually, or I can do a little math. I'm going to make these ones yellow. So that was 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. And so I can tell that there are 25 here. So how are 9 and 16 related to 25? Well, the two squares, again, are 9 and 16. And the last one is 25. Well, 9 plus 16, when you add them together, that actually equals 25. So now let's see how this works algebraically. If you go back to what we said, which was a squared plus b squared equals c squared, we can see this in a nice picture. So algebraically, a is 3, so let's substitute that in. B is 4, so we're going to substitute that one in. And now 3 squared and 4 squared, well, 3 squared is 9 and 4 squared is 16, and 9 plus 16 is 25. So how do we undo a square with a square root? So we're going to square root both sides, and the square root of 25 is 5. So we now know that the length of C is 5, but we already knew that because of the work we did with just the picture. But we can now state that we know that this right here is 5 long, and we can see that with the picture we drew. So this was just a nice little picture way of understanding what was happening. So now let's go on to the next example and do it without the picture. So we need to figure out what's A, what's B, and what's C. Well, remember, A and B are just legs, so I can put it in either place, it won't matter. So let's go ahead and put A as 8. And you might find it helpful to label the sides, and B as 15. So for example, I might decide to put my letters directly on here so that this says A and this says B. Some people will find that very helpful. But now we're just going to substitute into a squared plus b squared equals c squared. You need to write this down on every single problem, every time you start. And by writing this here down, this is going to help you keep track of your variables and what it is that you're looking for. Okay, so let's go ahead and do this problem. So now we're going to substitute in your variables. So A, you substitute in 8, and B, you substitute in 15, and C, we don't know, so it's going to stay C. So 8 squared is 64, and 15 squared is 225. 64 and 225 is 289. And now to undo that, you have to take the square root of both sides. And since you've taken the square root, it's now 17. Now we're not going to write the square root, again, because we did it. And we're not going to write c squared because we did the square root to get rid of it. So we now know that this hypotenuse is 17. So now let's look at this problem. On this problem, remember, if I go directly across from my right angle, that is my hypotenuse. So C is always opposite the right angle. So that means that 25 is C. And 7 is either A or B. It doesn't matter which one you put it in for. So we're going to go ahead and put 7 in for A and 25 in for C. And you're going to write A squared plus B squared equals C squared. So now you're going to substitute in what you have. So 7 was A and 25 was C. I now simplify those parts. So 7 squared is 49 and 25 squared is 625. I now subtract 49 off of both sides and you get 576. Again, I subtracted 49 off both sides. So now you have to take the square root to get to 224. So let me write some of those pieces in for you if you're not sure how we got there. This was subtracting 49 off of both sides. And then I took the square root to get to 24. Okay, this next one I'd like you to actually try it on your own. It's missing a lot of the pieces, but it also, you have some examples to look at. So try it on your own and then come back and we'll go through it. Okay, so now that you've tried it on your own, some of the things that I hope that you did. The very first thing I hope you did was I hope you wrote down that A squared plus B squared is equal to C squared. And then I hope you wrote down that the variables that you need to know are A, B, and C. We don't care whether you wrote down A was 9 or 12 and B was 9 or 12, but you do need to know that those were the legs. And then you substitute them in. And then after you substitute them in, you evaluate them each. So you should have that 81 plus 144 is equal to C squared. You could have 144 plus 81 is equal to C squared. It doesn't matter so long as that those two things equal C squared. And then once you add those together, 225 is equal to C squared. And how do we undo a square? We undo them with square roots. And so the square root of 225 is 15. So that means that our hypotenuse is equal to 15 meters. Thank you so much for joining us in the Pythagorean Theorem. What I would like you to do to finish up this lesson is I would like you to draw a diagram of a right triangle on your own and label the right angle, the legs, and the hypotenuse. Thank you again for joining us, and I can't wait to see you in our next lesson. Please remember to be nice to one another because we all can use some extra kindness in our lives. Bye for now.